All right, so now we're going to talk about calculating an effect size. And what we want to do is we need to find an article that will have some sort of an effect size on it. So I want to go to, let's say I want to know, let's say, Nova and reading. No, we don't even need to do that. Repeated reading. So I'll pick up one of these that has a PDF with it. So this is effects of reading, repeated reading and listening while reading on fluency, reading fluency. So what we want to do is we need to go down to their results. So at post-test, because we only care about post-test, we are seeing that repeated reading gave us 56.10, and listening while reading gave us 57.15. And this is on reading speed, which was the elapsed seconds to read passages. And then we have reading accuracy down here, and on the post-test we look exactly the same. The difference being that on the pre-test, the repeated reading scores were 75.05, and listening while reading was 57.15. And so it's hard to use, it can be hard to use post-tests when we didn't have baseline equivalency. And so because the baseline was off, this post-test is going to be a little bit wonky. So for our purposes, so they used a two-way analysis of variance, treatment by pre-test, post-test. The gains were made from pre-test to post-test for both treatments were significant for both reading and reading accuracy. So what we'll want to do to calculate the effect sizes is we go to, if we go to this website, and I'll put the link on the Canvas site. Generally speaking, we go to means and standard deviations, and we do the treatment group. So let me put this into two windows. Okay. So our treatment group was 56.10, standard deviation of 18.88, and then we need to figure out how many people were in each group. So I'm going to go ahead and put the rest of this information in, 57.15, 18.27. So then I need to find how many were in each group. And it's never easy to find all of the information. I don't know how this got. So it looks like 20. And we'll just use 20. So then I would calculate, and then we can see that D was negative 0.5, which differs from what they said. They said that, and they're right to a certain extent, that their repeated reading did better. And if we look at the gain score, it did do better. So So they're getting faster is essentially what we're looking at. So they're reading the same passage, but they're getting faster reading the passage, which isn't usually how we do these kinds of things, but let's give them the benefit of the doubt. So our gain was 18.95, our gain was 13.3, so repeated reading did better. So what we can do in instances where this is what they did, we can use the results total sample size was 20. From a two-way ANOVA. They're not going to give us this information either. So what we could do is we could an F test to group equal sample sizes. So we do 20, and then our first F here is 28.71, and we can calculate, and then we actually see a big D value of 2.3962, and this is based on this number So by doing it this way, we have in some ways accounted for the variation between the variation and or the discrepancy in baseline. But I'm not sure that we did it. So we can also get the correlation coefficient off of different things. We can get the odds ratio off of these different things. So if we can find the information, and sometimes that's the really hard part, if we can find the information, we can find one of these tests based on what they do. In standard practice, we would want to use the means and standard deviations from the post-test. Even better, if we have an ANCOVA, we would use the ANCOVA. Although that information is going to be really hard to find too. So and then in a two-way ANOVA, they would have to give us more information than they did in this study. But this gives you a general idea of how we would go about finding the effect size. So if you were the one that did the let's find something more recent. Maybe. Oh wow, they're not even going to give us a table. Oh, this is a single case design study, so that's not going to give us what we want. Let's see how this one does. Seven participants, so that doesn't do us any good either. Let's go back to anytime. How much that ought to put? So here we can see in condition 1 they were at 0.195, condition 2, but it doesn't give us the that might not be all that helpful either. So when we're doing meta-analyses, which is the whole point is to do these effect sizes, it can become really problematic because we have a hard time finding the information that we need. And a lot of these seems to be something that we can't use. So your job is going to be to find, even though it can be kind of difficult, to find an article that was a group design, and then calculate an effect size from it. And again, we want to start with means and standard deviations. If we can, we want to do means from an ANCOVA, but then you're going to have to find this information, which is probably not there. And so again, we're going to go to, we could use gain scores if we have the gain score standard deviations, and I don't think that did. We don't have that. There are formulas to calculating them more explicitly, but what I'm going to do is I'm just going to have you do your best, try to find a group design, try to find, and what it's going to do is it's going to show you the amount of people that publish studies but then don't give us the necessary information in the study to work from. So again, I'll have this online. I'll actually do it right now while you're watching, and then find an article, calculate an effect size from the article, and then upload the article along with the what you would call it. So upload the article and then also upload the Word document with the effect size on it. And that's it.